Welcome to this explainer. Okay, today we're cracking the code on the Cambridge IGCSE Additional Mathematics 0606 syllabus. We are diving straight into the core of how to secure those elusive top band marks. And we're going to do that by avoiding the high risk, yet, incredibly common mistakes that candidates just keep making year after year. Seriously, if you've ever walked out of an exam room feeling absolutely confident only to be completely shocked by your final score, well, you are in exactly the right place. We're opening with zero fluff today, mostly because the stakes are just way too high. When we look at grade boundary risks, a really fascinating pattern emerges. I mean, why do so many highly capable students lose easy marks? The reality is, you can understand the math conceptually, right? You literally know exactly how to solve the problem in your head, but you still end up dropping critical points on the paper. It's wild. The real tragedy of the 0606 exam isn't necessarily a lack of mathematical ability. It's actually a lack of alignment with how that ability needs to be translated onto the page, especially under intense exam timing pressure. To really understand why this happens, contrast the typical classroom focus, which is all about getting that correct final answer, with the examiner's strict analytical rubric. The examiners aren't just scanning for that magic number at the bottom of the page. No way. They're evaluating your analytical depth. They're looking at your logical, structured reasoning, your exact process, and yes, your exact formatting. So if you treat the exam paper like a sprint to the finish line instead of a showcase of your analytical depth, you're just leaving guaranteed marks on the table. All right, let's dive into Section 1, the High Marks Strategy Framework. Before we expose a highly specific exam trap, we really need to establish an impenetrable defense against careless errors. So walk with me through this 5-step standardized sequence. This right here is the exact systematic processing required for those complex 0606 questions. Step 1. Deconstruct the question and extract the relevant data. Simple enough, right? Step 2. Select your analytical framework. Now, Step 3, and honestly, this is absolutely massive, execute with clear notation, showing every single step of your working. Step 4 is verifying your results and double-checking your assumptions. And finally, Step 5, present your final answer using the correct terminology. Guys, this isn't just good advice. This is literally the DNA of a top-scoring candidate's exam paper. Which brings us to a core concept you absolutely have to internalize, the method mark strategy. Top-performing candidates show connected conceptual understanding through their exact process. That's how they secure those crucial method marks. The assessment framework heavily prioritizes how you actually arrived at your conclusion. If you just, slap down an isolated final answer, even if it's 100% correct, you're going to miss out on the majority of the marks. You're being assessed on undeniable, evidence-based reasoning, so you simply must provide the evidence. Now, in just a moment, I'm going to show you the exact examiner clue that changes an answer completely. It's the super specific detail that examiners actively hunt for, and leaving those details out, well, that means missing out on the grade you actually deserve. But first, you really needed that framework we just covered to make this upcoming clue incredibly obvious. Moving on to Section 2, the Tangent Graph Trap. Let's unveil one of the most misunderstood areas in additional mathematics. This is a trap that consistently ruins top grades. Here's the specific rule that candidates casually ignore all the time. For a tan graph, you must clearly label the x-coordinate of any asymptote. I know, it sounds almost annoyingly simple, right? It's totally maddening to think about losing points over a tiny dashed line. Yet, principal examiner reports highlight this over and over again as a major source of lost marks. It's just not enough to draw that dashed line. You have to explicitly extract points from this exact requirement by providing the actual mathematical label. Now, what's really interesting when we break down the psychology of this mistake is that 3 top examiner warnings emerge straight from Cambridge. Number 1, candidates forget to include the proper format. Number 2, they forget to check their presentation, meaning their graphs are, a bit sloppy or just incomplete. And number 3, they provide generic answers that aren't specific to the context given in the question. Honestly, I highly recommend using this as a mental checklist every single time you encounter a graphing question. And this brilliantly illustrates exactly what we've been talking about. Just listen to the undeniable authority of the Cambridge principal examiner's own words here. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Guys, they are practically begging you to be specific. If the question gives you a specific domain, or say a specific real-world context for the tangent function, your asymptote label absolutely must reflect that exact context. All right, let's jump to Section 3, Fixing Flawed Student Answers. Let's shift you from a passive listener to an active exam candidate right now. Let's see if you can spot exactly where a typical student throws away their hard-earned marks. Looking at the flawed example, we see a very common, fundamentally flawed answer. The student has drawn a really beautiful dotted line for the asymptote, sure, but the x-axis is entirely blank. Just pause for a second and predict exactly what the examiner is going to write in red ink next to this. Now take a look at the improved top band answer. Here, the candidate perfectly executes the method mark strategy. They clearly label the exact x-coordinate of the asymptote, and they specifically link it to the contextual scenario provided in the prompt. That tiny little addition, that's literally the difference between an average grade and a top-tier grade. Section 4, Securing Top Band Marks. Ultimately, you secure marks across all levels, not just by, doing the math, but by communicating undeniable mathematical proof directly to the examiner. So the crucial point is this: success in 6060 really requires a marriage of high-level strategy and microscopic attention to detail. Whenever you sit down to practice, use this final checklist. Deconstruct the question, extract the data, apply the relevant principles, execute with crystal clear notation. And seriously, if you see a tangent graph, always label that x-coordinate. Bringing together this core methodology with the specific syllabus requirements is exactly what's going to provide you with total clarity on exam day. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Okay, we've successfully fixed the tangent graph trap today, but graphing is really only one part of the paper. Here is a vital question you need to ask yourself right now. What exact examiner language is secretly destroying your algebraic manipulation scores? Because guess what? There are hidden command words in the 0606 syllabus that require completely different mathematical approaches, and misreading them, that routinely costs candidates up to a whole letter grade. We are decoding that exact examiner language next, so jump right into that explainer now to protect your algebraic scores.